If I were to use GW3D tools to build a speedboat, this is how I would approach it. My goal is to create surfaces which are large enough to support manufacturing. So, for example, this guy comes to a point, and you can make a three-sided surface, but it's very difficult to manufacture anything out of it. So what I do instead is I will take the control curves, or the theoretical stuff that you can pull from a drawing, and in this case I want this plank to be linear between this theoretical curve and this theoretical curve. So I've created a set of planes that limit the upper ends and the lower ends, and so there's just a intersection point, a line through it, and then the lines are more or less extended up to these two planes. And what that does is it creates a nice surface which is wrappable and flat pattern. You can use it to create a flat pattern. As you can see, all the flow lines in this direction are linear. So the twist is along the center line of this, and so this end of the surface is twisted in and this end is twisted out. A lot of cuts need to be made towards the edge or the end of the part so that you can get a nice straight intersection. So most models are working towards a 2D drawing where you have like the side, like a cut, a step and a cut, but there's a million ways that you can create a surface that would produce that. The goal here is to create something that is manufacturable. So this guy down here is also a four-sided surface. So if you imagine this, you'd take a plank which was rectangular and you'd cut that shape out. You could also use your extended surfaces and kind of bolt the side of the boat together. You have this chine right here that breaks up the bottom V with the freeboard on the side. So this shape is hard to get to actually come to this end right here. So you've got this face, and this face all intersecting at this one point. And if you can get that figured out, then you have a successful surface that you can use to manufacture. When I say manufacture, like we can make a flat pattern. So we take a flat pattern. In this case, we'll grab the four edges. We'll take the surface, and we're doing surface to plane, and we're using the geodesic flat pattern. So the geodesic preserves internal surface area as best it can, and so we're going to use this surface. We're going to go to this plane, just slap it onto that plane out here, and then we use a geodesic center point, which is roughly the middle of the area, and that projects it out to the plane, and that's the shape that you would cut out of a flat plank, and then you would bend it onto the boat. Likewise, we could do that with the bottom as well, which is three sides. But the surface actually has four sides. We're just going to trim a three-sided piece out of that surface. We're going to project that down to the Z-plane. And remember, it's not technically a projection. It's a calculated flat pattern. And we can look at the error. So this is calculating the perimeter curves. And then the projected curves, as you can see, they're within a small fraction of the same length. Flat patterns are never truly the same length, but if you can get them close, within, in this case, less than 1%, then you've got yourself a good solution.